Hello, myself Sarthak Sabde and I am from Division B. My roll number is 105. My first problem is FKP problem, that is fractional nature problem. The question is given below. In the question, weight, profit and capacity is given. We need to find the optimal solution. In step 1, there is a definition of FKP. It is one of the variation of classic Nassau problem where we are allowed to take fraction of items rather than choosing entire item. The goal of FKP is to maximize the total value of profit. For given problem, n equals to number of items, v equals to value, p equals to profit, r equals to ratio, w equals to weight, c equals to capacity. Let's move towards the step 2. In step 2, we compute ratio. Ratio means profit per weight. Let's see. Here we calculate the ratio like profit per weight 6 divided by 12, that is 0.5. In the next step, we sort the ratio in descending order. Here we sort the ratio in descending order. In the step 4, we need to solve with greedy method to find maximization. Let's consider I equals to 2, that is item number 2. Item number 2 has weight 2, that is less than equals to given capacity 25. Remaining capacity equals to 25 minus 2 equals to 23. We need to calculate profit. The given profit is 4, that is given equals to profit equals to 4. Let's consider I equals to 3, that is item number 3, and it has weight 1. 1 is less than equal to previous remaining capacity, that is 23. Now the current remaining capacity equals to 23 minus 1 equals to 22. The profit equals to previous profit plus current profit equals to 4 plus 2 plus equals to 6, that is 6. Let's consider I equals to 6, that is item number 6. That has weight 6, that is less than equals to previous remaining capacity 22. Now the current remaining capacity equals to 22 minus 6 equals to 16. Now the profit is previous profit plus current profit equals to 16. Let's consider I equals to 7, that is item number 7. Item number 7 has weight 10, that is less than equals to 16. Remaining capacity equals to 16 minus 10 equals to 6. Profit equals to 16 plus 8, that is previous plus current equals to 24. Now consider I equals to 1, that is item number 1, but we need only 6 weight. Item number 1 has 12, that is not fair. We need only 6 weight. Remaining capacity equals to 6 minus 12 minus 6 equals to 0. Now we need 6 weight profits. Here we can fraction. 6 into 6 divided by 12, that is 36 by 12 equals to 3. Now the 6 weight profit has 3. Therefore profit equals to 24 plus 3 equals to 27. That is the maximum profit. There is no remaining capacity, that is why we skip the item number 5 and item number 4. In the last step, we need to write the solution. The optimal solution of FKP using greedy method are 27, that is maximization profit, and the FKP item set equals to like this. Now my second problem is Prim's algorithm problem. This is my graph and given question that has 7 nodes and edges and has their weights. In this, step 1 is definition of MST, GM and Prims. MST, it is the subset of all the edges of connected undirected edge weighted graph that connected all vertical together. What is greedy method? It is a problem solving approach that makes the locally optimal choice at each stage with the hope of finding a global optimum. Third is Prim's algorithm, that is very important. It is a method that starts with a single vertex and repeatedly adds the smallest weighted edge that connects a vertex in the growing spanning tree to a vertex outside of it until all vertices are included. Let's see the step 2. I can rotate my mobile. Step 2 is manual tracing of Prim's algorithm. In this, we need column I, that is iteration, J and K, that is H, and other are A to G are nodes, and last 2 columns is helping nodes and minimum cost. Helping node and minimum cost. Let's get the first iteration, that is A and B. Why A and B? Because A and B has minimum weight. So we get the minimum first because it has a minimization problem. So the edge A and B are put here. Then we get A to A node, B to B node dash, B to C node that has weight 2, A to D node that has weight 4, B to E node that has weight 4, F and G has no edge between A to B. So helping node is A and B, and minimum cost is 1. Let's go to the second iteration, that is B and C. Why B and C? Here j equals to k, that is b put on the j side, and the previous minimum value, that is b weight 2, that is c put on the k value. So A, B and C nodes are dash, then A to D edge are present, that is 4 weight, and B to E edge are present, that has 4 weight, and C to F edge are present, that has 6 weight. So helping node is A, B, C, and that minimum cost is 1 plus 2 equals to 3. 2 is the previous minimum cost. Let's see the third iteration, that is also same like previous. J equals to k, that is c in the j, and previous minimum value, that is 4. There is 4 value here, and we get any one of them. We get first one 4, that is d put on the k value, A, B, C, D, that is dash, and D to E there is h, that has weight 3. C to F, that has weight, that has h6. D to G, that has weight 4. The helping nodes are A, B, C, D, and the minimum cost is 3 plus 4 equals to 7. Let's see the fourth iteration. This is also same as previous. J equals to k, and the previous minimum previous value equals to k. Then A, B, C, D, and E and F has no h, that has weight 8, and D and G has 8, that has weight 4. The helping nodes are A, B, C, D, E, and minimum cost is 7 plus 3 equals to 10. There is minimum value is 4, that is G. There is fifth iteration, E and G. E comes from case value, and G comes from previous minimum value. A, B, C, D, E, that is keep dash. F, G and F has H, that is cost 3, and G to G dash, there is helping node A, B, C, D, E, and G, and their minimum cost is 10 plus 4 equals to 14. Then the sixth iteration is G and F, G from K and F from previous minimum. So the helping node is A, B, C, D, E, F, G, and minimum cost is 14 plus 3 equals to 17. This is the minimum cost. Now let's move towards the step 3, that is we need to generate the MST using Prim's algorithm pictorially. Here we get the first iteration as per table A and B. We draw A and B edge. There is second iteration A, B, C, helping node A, B, C. There is A, B edge and B, C edge. There is a third iteration, that is A, B edge, B, C edge, and A, D edge. Let's see. There is fourth iteration A to B, B to C, A to D, and D to E. There is fifth iteration A to B, B to C, A to D, D to E, and E to G. There is sixth iteration A to B, B to C, A to D, D to E, E to G, and G to F. Now the last step of the Prim's algorithm is draw MST. Here we can draw MST, and the cost of MST is 17, that is minimum. Here is the last question of our assignment, that is dynamic design algorithm paradigm. The dynamic programming is a design technique used in algorithm where a problem is divided into smaller subproblems, and the result of these subproblems are shared and reused to avoid solving the problem again. The main features of DA equals to divide problem into subproblem, stores answers of subproblem in a table or memory, reuse shared answers whenever needed, build a final solution step by step. Why we use DP? Problems has overlapping subproblems. Same subproblems appears again and again. Problem has optimal substructures. Base solution can be built from smaller base solutions. For example, Fibonacci sequence, shortest path problem, Nash-Nash problem, matrix chain multiplication, etc. Thank you. This is my CI1. Thank you.